Hello, welcome to another edition of Turbo Delphi Demos. I'm Nick Hodges, the Delphi Product Manager, and today I'm going to be talking about constructors and destructors. Now, the last few demos have had the theme of classes and how classes work, and so today I'm going to continue that theme by talking about constructors and destructors. Mostly about constructors, because destructors are actually pretty straightforward and simple. Constructors are a little trickier, so we will deal with them mostly today. Okay, I'm going to start a new project, a console application, as we've done with most of the demos before this, and I'm going to add a new unit to it so we can add some classes into that unit. And I'm going to save everything here. The first unit I'm going to call Constructor Demo, just for the sake of argument, and Project 21 will be our project. Now within the interface section, once again, I'm going to declare a class. Another simple class. I'm just going to call it demo class, and I'm going to have it descend from the object that is the base object for all classes in Delphi, T object. Now, in the past, you've seen us use this unit here, and then you've seen me, declare a variable called. Most often, we just would simply call it the name of the class without the T. So in this case, demo class equals is a type T demo class, and then you see me do something like this: demo class gets T demo class dot create. Now that call to create is in fact making a call to a constructor, and a constructor is a special kind of member or method on a object that allocates memory and initializes the class and returns a pointer to that class. And don't worry about the term pointer. Actually, I'll use reference. Reference is the probably a better word to use. And a reference is, this is the reference, i.e. it is a identifier, a variable that represents the class as it sits in memory. Now, of course, this class doesn't do anything, obviously, at this point, but it does have a constructor, and that is because T object has a constructor. And I will press down the control button, I'll click on the word T object here, and it'll take me to the definition of T object. And you notice that T object has a constructor called create, and for later's reference, it also has a virtual destructor called destroy. Now, the create name for constructor is convention. It's just a normal word that we use to denote a constructor, but you can name your constructors anything, as we'll see in a minute here. But to add a constructor to a class, you do use the special keyword constructor, and then you give the constructor a name, just like you would any other procedure. And now we have a declared constructor. I'm going to hit Control-Shift-C, and we have now an implementation of it. And generally speaking, the first thing you do in any constructor is you call the inherited constructor. In other words, we're descending from T object, so we want to call the inherited constructor first off in our constructor, because that will do any constructing that needs to be done by parent classes. And in rare cases, you won't call inherited, but most of the time, you almost always should. Now, constructors, the purpose of a constructor, as I said, is to allocate memory, initialize variables and values, and return a reference to the class created. Now, constructors obviously need to be public, and we talked about public, private, and whatnot in the last demo. And they need to be public, otherwise you can't use them. Now, there may be, again, exceptions to that rule for specific purposes, but as a general rule, vast majority of constructors will be public, so they can indeed be called by the someone who wants to construct an instance of the class. If you don't have a public constructor, you can't create an instance of a class unless you are creating an instance of that class in a descendant class or a class in the same unit. Be that as it may, 99.99% of the time, or whatever, you're going to have a public constructor. Now, constructors are generally, as I said, public, and one of their main jobs is to initialize. Now, if I declare a variable of some integer of type integer, then what will happen is the constructor will create the class and initialize some integer to be 0. If I have a string, type string, it will initialize the class and initialize the sum string variable to be an empty string. So just to illustrate this, let's do a little work here. We can call write a procedure called write out self, and we'll implement it, and we can say write out self. We can call it, whoops, I'm sorry, I'm not going to call it yet. What am I thinking? We can have it write out the values that we are, right, len sum integer equals, and then we can add another integer to some integer, like so, and then we can control C, V, we can change this to some string, change this to some string. Now if we go over to project 21, we can call demo class, we can say try, finally we can say demo class dot write out self, and then we'll free the demo class in the finally block so that it ensures. And now if we run this application, we should see nothing because we forgot to put a readlen at the end. So now if we run it, we can look up and we'll see some string equals 0, or some integer equals 0, and some string equals a empty string. Well, that may be fine. A lot of times you want your variables and your members to initialize to initial values, but sometimes you don't, and that's where the constructor rolls in. So for instance, if we wanted to construct an instance of this and set a value for some integer, say to 999, and and we wanted to set some string to some other variable not empty, right, not an empty string. Now if we save this, run it, you'll notice that the constructor has done the job of initializing variables to something other than the default initial values. So that's another role of the constructor, to initialize variables. And if you have special initialization that need to be done, you do it in the constructor. Now, constructors can have more than one name. They don't have to have constructor. You can have more than one constructor, and you can call, say, a constructor called create with values. So we can pass in a integer as parameters, a string, value string, and I'm going to go ahead and unpin all this stuff so that we can see more code and less of this stuff. And now I've got a constructor that's called create with values, and I'm actually passing in some values. And this is a fairly common pattern for writing constructors. Now if I hit Control-Shift-C, it'll create a new stub for this. And now I can once again call inherited create, which is the inherited constructor. But then I can go in and I can set the values for my fields using the passed in. Using the passed in values here. Some string gets a string, and then just as an aside, I, as convention, put a in front of all the parameters of any methods, procedures, and functions to distinguish them as parameters. So I know that variable names that start with a are parameters. So if I'm inside of a function, I know that this value, that was a parameter passed into the constructor. So now if I come back over to my project and I say, instead of just ordinary create, I can call create with values, and I can pass in an integer, and I can say I can pass in a parameter string here, close the parens. Now when I run it, you'll notice again that when it writes itself out, it receives the values from the constructor, sets them inside the constructor, and thus initializes the object. Another thing you'll frequently do inside of constructors is create instances of classes that are members of your class to be constructed. So for instance, if I just create tsum class equals class descends from t object, and then I create a variable called sum class of t sum class, then you know that sum class can't be used until it's been instantiated or created. So since I have sum class, which is a field of demo class, inside the constructor I need to create an instance of that class. So in the constructor I need to say sum class gets t sum class dot create, and that's initializing the reference to sum class. Now if I don't do that, sum class will point to nothingness, and anytime I try and use sum class I'll get an error in my code, a runtime error, because sum class hasn't been properly initialized and created. But I have now in this code properly initiated and instantiated an instance of sum class, which now can be used throughout the rest of the object after it is created. And you'll notice I also need to copy this class down into the sum class code as well. Now, since that's repeated code, another convention that's often common is for the class writer to create a method called initialize, or some such name here. And in the initialize class, you take this code and drag it and move it down here, and then replace it with a call to initialize. And if you have multiple constructors, this can save you a little bit. Initialize. This can save you a little bit of time, and I'm going to hit Control-Shift-C, and that'll create a stub for me called initialize. It's now private because nobody else needs to call it, just the internal class itself. And actually, as we know from the last demo, I actually, to be precise, ought to create that as strict private. Now, that enables me to centralize the initialization in one method that can then be called by multiple constructors. So for instance, if I had other classes, I would end up with more calls inside this, more creation calls inside this initialize method. Now, if you remember correctly, I've always told you, whenever you create an object, you need to destroy it. And of course, we are creating some objects. We are creating an object inside these constructors here. So when the class is destroyed, we need to call a class destructor. Now, destructor on TObject is actually a virtual destructor, and it is possible to have other classes, other destructors named destroy, other destructors named something other than destroy, excuse me. But I would say that inside Delphi and inside programming in Delphi, there's absolutely no reason to do it. All destructors should be really named destroy, and all destructors should be overridden. You should call override on all destructors. Now when I hit Control-Shift-C, it'll give me a stub. And you'll notice that before we always called inherited create first, with rare exception. With destroy, we always call the inherited destroy method last. Now destroy's job is to release memory, clean everything up, and release the reference and the information and the class instance itself from memory. So the first thing we should do is we should clean up after ourselves. Now, for ourselves, we've created this instance of some class, so we should call sumClass.free, and that will release the memory for our internally held reference sumClass, and thus not leaving a memory leak from leaving behind an instance of tsumClass. Then, of course, we'll call inherited destroy, which will then go on to destroy. We'll go on to call the destructors in the parent classes of all these classes in the class hierarchy above us. Now, you may wonder why we don't call sumClass destroy. Instead, we call sumClass free. I'll hold down the Control key and click on free, and you'll see that TObject free calls destroy as long as as long as self is not a nil reference. And nil means a reference that refers to nothing. And as long as this reference is not referring to nothing, it calls destroy on TObject. Now, TObject's destroy has nothing in it. But if you remember from what I was talking, remember from the demo in polymorphism, you'll know that when I call destroy on TObject, if there is an overridden destructor, as there is here, that will be the destructor that gets called, and then the inherited destroy call here will work its way up the chain, calling all the destructors of all the classes up above in the hierarchy. So that is what a destructor does. That's it. So basically a destructor should be declared as destructor destroy. It should always be overridden. It should clean up any memory that the object itself has allocated. In this case, we've allocated an instance of tsum class, and then it should call inherited destroy. That's what will happen in, again, in 99.999% of your destructors. So that's the quick look at constructors and destructors. Appreciate your attention, and I'll see you next time on Turbo Delphi Demo.